Hello and a very warm welcome back to Maths Plus. We're doing the Leave Insert question 5 in the 2022 paper 1. This section is based on calculus. So you can see there in question 5a, the first part, we want to get the differential of the function g of x. So we've got to use differentiation. It looks tricky there with the 1 over x, so let's see what we're going to do there. And then on the second part, we're given a factor of the cubic, and we need to find the three values for which f of x is equal to 0. Well, they're going to be the other roots, okay, apart from the root related to this factor. So we're going to do long division there. Alright, so let's start off with the differentiation. So in your log tables, you could look up at page 25 for the differentiation formula. And remember, always do it in two steps. So if we have g of x and we want to go g dash, which is the differential, the x squared will become the 2x to the power of 1. So we just write in our powers at the start. And also, we're going to rearrange the 1 over x before we start differentiating. So 1 over x is equal to x to the power of minus 1, as the power below is 1, and when we bring it up, it's a minus 1. So then we differentiate that in two steps. So the minus 1 will go below. So if I do dx to the power of minus 1 dx, okay, the minus 1 will go out in front, so that means that I'll bring it back up here, so it'll be minus, which is part of the question of g of x, and we will bring down the minus 1, and then we'll subtract 1 from the original power, so we'll have minus 1, minus 1. Alright, so we have all the steps done, so all we have to do now is to put everything together without the numbers. So the minus 1 and the minus 1 will give you a plus when you multiply, and the power at the top now is x or minus 2. So remember, x or minus 2 is going to be 1 over x squared. Okay, so from your log rules, so our final result will be 2x plus 1 over x squared. Okay, so just recap that again. The 1 over x is actually x to the power of minus 1. You apply the differentiation rule, so bring down the power in front and we get minus 1. Then we'll subtract minus 1 from the original minus 1 and we get a total of minus 2. This then becomes 1 over 2. So a lot of parts, okay, but do it in stages and take your time. Alright, so let's go on to the next part. So we're back onto cubics and the factor theorem. So remember, a factor, okay, by a quadratic, okay, will be equal to the cubic, you know. So we just go ax squared plus bx plus c, give it a generic format, and that's equal to a cubic, you know. So we just say f of x cubic. Alright, so now we have our statement, and we can do the maths now, because we can divide the cubic by this factor here, and that will give us the quadratic. Okay, so divide across over here. Alright, so let's put it all together. So we do the long division, x plus 1 to 2x cubed minus 21x squared plus 40x plus 63. So the first term will be 2x squared, and let's multiply down. So 2x squared by 1 is plus 2x squared. So then I'm going to subtract and change my signs. So I get a plus or a negative and a negative. Alright, so that will give us a result of minus 23x squared. Bring down the next term, so we bring down our 40x plus 40. Alright, so our first term now is minus 23x squared, and x into minus 23x squared is minus 23x. Minus 23x, and multiply out. Okay, so you can see what I'm doing. And now we'll subtract. So change the signs. So let's just change the signs. We put them in green so we can see what's going on. So that's a plus now. And that will be a plus as well. Okay, so it's working out. And we get a plus 63x. We'll bring down our plus 63 now. Alright, and then we're going to get a final term of plus 63. So we get plus 63x plus 63, and we'll subtract, and we get 0. Okay, so that's awesome. So we have the cubic divided into by the factor. Okay, so that will give us a quadratic. These two are the quadratic. So we got to factorize this now, and then we can get the two roots. So we're going to factor the quadratic. Okay, so let's get that one. So 2x squared minus 23x plus 63. Well, let's look at the numbers. Okay, so we want to get a 63 and a 23 in the center. So the cross multipliers will be, we'll have a 2x here and an x here. And then we have a 7 and 9 to make 63. So we can multiply these 2 by a 7 and 9 by x. So 7 by 2 is 14, and then plus 9 is 23. So we've got it minus both of those, okay, because we need to keep the signs negative to make a plus 63, and set them both to 0 separately now. So 2x minus 9 is equal to 0, so x is equal to 9 over 2, or 4.5. And what about the other one? X minus 7 is equal to 0, so x is equal to plus 7. And the final one was x plus 1 was equal to 0, was the original up here. And then we'll have x is equal to minus 1. So there are our three roots. Okay, so let's move on to the next part. Alright, so we have our graph as well, and you can see there the cubic will cross over the axis at 3 points, which are the root points, okay, and the solution for f of x is equal to 0. Okay, we're on to part 2 now. So find the range of values for which f dash x is negative, correct to 2 decimal places. So let's interpret this. So if we go back here to our graph, where is f dash x equal to 0? Well, we've got to make sense of this. Okay, so f dash x is actually the slope value or the rate. So the rate will be equal to a negative value when the curve is going downwards. Okay, so it's going down over here. So that means that if we get the points here and here, okay, which are the turning points, then between those two turning points, the graph f dash x will be negative. Right, so let's get our turning points, which we can refer to as our max min. So for the max min, we know that the slope is 0. So f dash x is equal to 0. Okay, because at the top and at the bottom, okay, the max and the min, the slope is equal to 0. Alright, so now we have to differentiate the function, and let's see what we get for our differentiation. Well, f dash x is equal to 6x minus 42, 6x squared minus 42x plus 40, and we know that's equal to 0. So just a reminder, The original one is 2x cubed minus 21x squared plus 40x plus 63. And you can see the 63 will go to 0. The 40x, you'll cancel the x. The 2 will go down here. And the 3 will go down here. So we got it all. And it's fully correct. Alright, so now let's solve this. So I recommend do the quadratic formula. So we'll go a is equal to 6. B is equal to negative 42. And C is equal to plus 40. And let's put it all together real quick. So minus b plus or minus the square root of b squared minus 4ac over 2a will give us our two values for our max and min. So we're going to get x is equal to minus 42 plus or minus the square root of minus 42 squared minus 4 by 6 by 40 over 2 by 6, and we'll get a result then of 5.86 for the plus, and also we'll get 1.14 for the negative. Alright, so let's see what's going to be the result. So as you can see there, there's this blue line denotes the negative slope values, and we got the range of values. So x is going to be between 1.14 and 5.86. So as it's a range of values, we must state that x is greater than 1.14 and less than 5.86. Alright, and that's it for question 5 in the Leaving Cert paper 1 of 2022 higher level maths. And a big thank you to all my subscribers on Maths Plus. You're awesome, and keep a lookout for the next exciting maths video.